welcome to this video from BI System Builders with Russell Beach. In this module we're going to cover off metadata and something we call the metabook system. I'm going to be talking you through the drawings on the whiteboard that you can see in front of you. Just a quick walk through, you'll see at the top there's a data dictionary. Moving into the middle, something we call the metabook, the CS metabook. Down on the left hand side there's a kind of a red and a blue area where we're describing source system data. In the middle is a data model. Moving down from the data model you'll see business view and semantic layers. And then moving over to the right there's a picture of a functional spec and something called ETL and analytics. Okay, let me talk you through it. So first of all, what is business intelligence? Well, business intelligence is really simply the process of taking raw data trapped in source systems, in spreadsheets, etc., and turning that data into information. It frequently also joins up the data. So it's actually about data that's on a journey. Now, when we describe the data, we use the name metadata. Metadata is really data on the data. So metadata could describe something such as the data in this column is a char or a varchar or an integer. It has a certain precision. It's in the range x to y. There's an incident of missing values, maybe truncated. The definition is this, the glossary term is this, and so on and so forth. So it's data about data. But the metadata must carry right the way through the process to the end, to something we call analytics. Now, analytics tend to be clever reports. The data doesn't have to have analytics as the final end game, but it frequently is. So analytics are dashboards or reports, clever reports, that allow business users to analyze data. They can look at KPIs, they can frequently drill down, drill across. And the data in those analytics, which could be delivered and frequently can be delivered to the executive board, needs to constitute what we call trusted BI. Now, trusted BI is quality assured, trusted data, and it requires a single set of semantics. We'll talk about that in a moment. But when we describe the data in the analytics, we're still talking about metadata. And to achieve trusted BI, we must manage and control the metadata right through the whole end-to-end BI system. Now here's an example. When we talk about analytics, we're looking for a common language. You see it written at the top in green, a single currency, because information becomes the new currency for business. You can trade in information, you can make decisions in a timely manner with the correct information. But we need all to be using the same set of semantics. This is what is referred to as the single version of the truth. It should be non-contradictory. The single version of the truth is frequently booted around in business intelligence and data warehousing projects, but it's actually the Holy Grail, and it's very easy for the single version of the truth to become corrupt. So what do we mean by the single version of the truth? Well, here's an example. Just looking at in the red cloud area in front of you, you see a calculation. Net sales minus cost of sales equals profit. Fine. Net sales minus cost of sales equals profit. Well, obviously we need to define net sales and cost of sales. But once we have that definition, we can put a field in an analytic called profit. However, look at the next line. This time, something else. Net sales minus ABC costs equals profit. Well, hang on, I've got a problem here. I have profit and I have profit. They'll almost certainly come out with different calculations. One's using activity-based costing costs and one's just cost of sales. So if I'm looking at an analytic, how do I know what is profit and what is profit? Which one is which? So the general term profit is not good metadata. We need to distinguish, because the journey of the data through the BI system culminates in different calculations at the end. Maybe we could call one profit, cost of sales, profit, ABC costs. Whatever we decide to do, we need to differentiate these things. Otherwise there'll be confusions in meetings where someone reports on profit and someone else reports on profit and the figures don't add up. Here's an example of further confusion. Net sales minus cost of sales equals margin. Hang on. I saw that somewhere before. Net sales minus cost of sales equals margin. No, it doesn't. Net sales minus cost of sales equals profit. So now I have another issue. I have the same calculation, apart from in one scenario I'm calling it profit, in another I'm calling the result margin. Now this can easily happen because departments may use their data for their own purposes and have their own naming conventions, and that's fine. The issue only becomes when we take on an enterprise solution and we join up the data, which is the end game of BI. Once we start to do that, we need to control definitions, naming conventions, glossary terms, the calculations and the movement of data on its journey through the system. Okay, so how can we end up with this confusion? After all, we may have spent a lot of time, effort, and money to build a data warehouse, business intelligence system, pull out the analytics. There was confusion at the beginning with raw data, and now there seems to be confusion at the end. We'll just have a look in the blue cloud there, some of the examples of the diverse data that a business may be capturing. Legacy, file transfer protocol files, XML, third-party files, images such as blobs or other pictures, mainframe data, enterprise resource planning, ERP, operational data store, ODS, 3NF, third normal form, point of sale. That's such as if you go to a supermarket and at the till checkout, barcodes are scanned and that's recorded, CSV files, journals, maybe Excel spreadsheets held locally by departments. Data captured on the web, so page visits, number of clicks, etc. GPS, coordinates, so location coordinates, free text from contact centers, recorded conversations, master data management, and so on and so forth. So there really is a lot of diverse data, and of course we would expect that, because after all these data sources serve individual purposes for people, usually in individual departments. However, in BI now, to leverage the power, we're going to join this stuff up. In joining data up in a metadata system, one key tool is a data dictionary. Now primarily the data dictionary is served up, it needs to be in a place that can be accessed. You don't want multiple copies of it, so something like SharePoint or some repository is ideal. It needs to be under change control. And if you look at the middle of the data dictionary there, you'll see the business name. So if someone's working with an analytic, they can look at the business name and immediately find the calculation. So I'm looking at the business name net sales. The calculation tells me in the next column sales minus C1 plus C2 plus C3 is net sales. Okay, the glossary term in this case tells me C1 equals returns, C2 equals damage, C3 equals shrinkage. Okay, so I have immediately insight into this data via the data dictionary. Now there must be no contradiction in the data dictionary. It has to be rigorously maintained. So the data dictionary gives me other information, such as whether the KPI or the metric is an enterprise, in other words global or across the whole business, or just a local one. I can find the column name in the table that data is coming from if I want to, and I can even see it back at the source. So we'll cover off the data dictionary in more detail. This is just an introduction, but the data dictionary becomes critical to provide metadata about the data. That's data about the data. It describes the data for business users. In order to control the metadata, because BI systems and data warehouses can become very complex, we use something that we call a metabook. Now, there's a whole video on the metabook. But basically, the metabook contains all types of metadata about a data element. So it holds a data dictionary, which is a variation of the one that we just looked at, because it has some more technical information that can be used by developers. It will have the target schemas. It will have a physical dictionary of the physical models, a logical dictionary. It will describe measures. It will describe dimensions, fields, and it will also include the original requirements, so we can get a complete view. And the most important thing from this data dictionary is that it is managed and maintained and controlled, and then it populates the data dictionary. And you'll see from here we have on the right hand side naming convention standards and standards. If you decide on terminologies like date, some people like to call a date, refer to it as DT, it's a bit shorter. Unless the name's long, it often seems better to be more explicit. But if you do use something like DT instead of date, use it consistently across all of the data warehouse. Don't call it DT somewhere, date somewhere else, lowercase dt here, uppercase date over there. Standardize everything and rigorously apply the standards. Otherwise your data will go out of control. From the metabook we can also derive business rules, and the business rules will help us with ETL transforms. Now the business names and calculations and definitions, not always but often, feed off into some type of data model, because after all we need a structure for reporting, and then they're translated for use by the business user through some kind of business view or semantic layer or mapping layer or data model abstraction. But that semantic layer needs to hold the business names, the calculations and definitions for all the objects, all the fields in the end analytics, and the business view and semantic layer needs to be in complete synchronization with the data dictionary. The naming conventions need to be agreed across departments. Now the business rules are very important, because business rules driven by business requirements form the definition of various calculations and KPIs. And they are frequently translated into the ETL pipeline. So ETL, if it's new to you, stands for extract, transform and load. It simply is a program which can pick up source data files, transform them, that is, clean them or change them, dedupe them, apply calculations, merge fields, so on and so forth, and then load them into a target schema. The business rules in the metadata book, in the meta book, are critical to writing functional specifications which provide for us the ETL mappings. In other words, this source field maps to this target field, and the business rules, in other words, in the ETL code, the rule is to create this calculated field, take field A and then subtract B minus C minus D minus E equals, and load that. We also may have various types of error handling and something called RDDs, or report design documents, can come out of the functional spec too. And that was a brief walkthrough of the MetaBook system, and in the next video we're going to drill into the data dictionary and into the MetaBook in some detail. Now, if you're fortunate enough to have a program, an IT program, a piece of software which will trap the metadata for you, and there's several of them around, you can try to use that. And what we're talking about here are principles, ideas, concepts for controlling and maintaining metadata to ensure a single version of the truth. If you don't have a program, don't worry, you can maintain the information in Excel spreadsheets, etc. Although obviously you have to be careful around change control. Well, I hope this video was useful, and I'll see you in the next video. Thanks for listening.